Good evening. I am Dr. T.S. Saronan, Assistant Professor, Department of Computation Intelligence, SR Institute of Science and Technology, Kataguru. I am going to handle best first search. So in that best first search, you are going to see about the example problems. And best first search is an informed searching mechanism. In that informed search mechanism, here we are going to consider heuristic function h of n. H of n is the deciding parameter to find what should be the next level of process. Which node should be processed next? Everything is decided based upon heuristic function. So f of n equal to h of n. And even we are going to implement based upon priority queue. When we are going to implement using priority queue, we will maintain a fringe in ascending order of f values. And the next, we will be seeing about the steps. We will be creating two arrays. One is open and closed array, fixing the goal state, and we will be moving from the initial element from the open array, checking whether the element is going to be the goal state. If the element is the goal state, termination is done. If the element is not in goal state, we go for the next level of process based upon the minimal heuristic value generated. Arrange the elements in increasing heuristic order in open array. And we are going to repeat the process till we reach the goal state. This is the example what we are going to see. This is the example. Here, S is the source node and G is the target node. Here, first, as per the instruction, what we have seen, we will be having open and closed. Initial element should be placed in the open array. Here, initial element is S. S is placed in the closed array, so open array. And when S is placed in the open array, now it is going to check whether the value S is equal to goal state. If the value is equal to goal state, you are going for termination. If the value is not equal to goal state, you are going to send the value in the open state to the closed state, and you are going to populate the directly connected edges to the open state. Now, open equal to the directly connected edges of S, because S is not a goal state. Directly connected nodes of S are A and B. A, comma B. Closed is equal to S, which is the processed node. Next step is we are going to find the heuristic value A and B. When heuristic value A and B are going to be calculated, heuristic value A is 12 and heuristic value B is 4. The minimal heuristic value is considered and that is taken as the promising node for next step of action. So A is equal to 12 is ignored. So open state will be having A and closed state will be having S followed by the ignored value A. Now here open state, now closed state has S comma V, which are processed. Now open state has A comma the directly connected edges of B. Directly connected edges of B are E and F. So we are going to place E and F or the directly connected vertex. So we are going to place this in the open state and heuristic value of E and F are going to be calculated. Heuristic value of E is 8 and heuristic value of F is 2. When heuristic value is going to be calculated, the minimal heuristic value is considered as the processed and the processed heuristic value vertex is placed in the closed and unprocessed is placed in the open. Here we have F as the processed node, so we are going to place F in the closed. So S comma B comma F, A comma E is placed here. When a processing is done, what we have to check whether the elements in the closed are equal to the goal state. Here S, B, F are there. S is not equal to G, which is the goal state. B is not equal to G, which is the goal state. F is not equal to G, that is a goal state. So, as it is not equal to the goal state, the node which is moved to the closed node, the directly connected edges of the node moved to the closed state is considered. F is moved to the closed state. So, I and G is going to be placed in the open state. After placing I and G in the open state, the heuristic value of I and heuristic value of G is going to be checked. Heuristic value of I, it is 9. Heuristic value of G, it is 0. Now, G is going to be considered and it is placed in the closed state as the heuristic value of G is very less. So, open state will be having A, comma, E, comma, I. Closed will be having S, comma, B, comma, F, comma, G, which is the processed node. When something is newly added to a closed node, we will check whether the value added to the closed is equal to the goal state. Here, G is added to the closed. G is also the goal state. So, no more nodes are going to be processed and termination is done at this point. And advantages. Best first search can move between BFS and DFS. Advantage. Best first search can switch between BFS and DFS because it can no concept about the path cost is considered. We are going to consider only based upon the heuristic function alone. If the heuristic value is less, we process, else we are not going to process. The algorithm is more efficient than BFS and DFS. Because when in breadth first search, we are going to see only about the vertex values and only about the edges alone. Here, a deciding parameter is your heuristic function. Based upon the heuristic value only, the promising node is found and expansion of the node is done. Disadvantage. As only heuristic function is going to be considered, not going to consider path cost, we can say the algorithm is not optimal. And as only heuristic function is going to be calculated, depth first search may lead to a loop. Only the deciding parameter is only the depth first function, then it may lead to a loop. These are the various advantages and disadvantages of your best first search.